Okay, guys, this is homeostasis, and once again, homeostasis is really a simple process, and if you can nail that first definition, then you are going to be on your way to being able to work out what we do. And so the first thing I want to do is to mention two things that we need to know. And the first is what the definition of homeostasis is. And I want you to remember in our Rackham's rules and good exam technique, we're thinking about numbers of points that are required to get in order to get the marks. And the definition of homeostasis could easily be a 3-point question where you get 3 marks. And so if you look at the screen here, homeostasis means, here we are, maintaining a constant internal environment. So keeping conditions in the internal body relatively constant. Okay, now maintaining, okay, 1 mark. Constant, 1 mark. Internal body environment, 1 mark. So in 4 words, you've got 3 marks. And they are, like osmosis is the movement of water through a semi-permeable membrane from an area of high water potential to low water potential, which is bang, bang, bang for the marks. This is bang, bang, bang for the marks. And so you've got to create a link between maintaining constant internal body environment in order to define homeostasis. Now, when you know that's the case, that actually makes it quite straightforward to think about what homeostasis is or what homeostasis does in terms of our bodies. Before we do that, I'd just like to mention why we need homeostasis. Well, you now are forming, and I know you are, a really good feeling of why everything works, particularly in our bodies. And the answer is that most of it is based upon enzymes and enzyme action. You know that temperature affects enzymes, and you know that pH affects enzymes. And one of the main reasons that we keep things stable is that we want the reactions in our body to happen in the way we want them to. You cannot have a situation where we rely in respiration on the breakdown of glucose with oxygen to form energy, carbon dioxide and water, which are waste products, to get the energy. You can't have a situation where we haven't got a really nice constant supply of oxygen. You can't have a situation where we haven't got a nice supply of glucose. And we can't have a situation where the enzymes won't work at a temperature which allows the reactions to happen. Oh my goodness, what are the 3 things that we talk about in homeostasis, regulating? 1, we talk about regulating blood glucose levels. Why? Because respiration is what allows us to live, and if you don't have a constant supply of glucose, you die. So you can't be having spikes up and down, because you're in danger. You need to have glucose the whole time. There it is. Secondly, what else do we regulate? We regulate temperature. Temperature? Oh my god! Rackham's rules, temperature goes with enzymes. Enzyme are the reason that all reactions happen, pretty much. If you screw around with temperature and it goes up and down too much, you're not going to have the ability for respiration to take place. Respiration needs oxygen. Oxygen, think about the way we regulate our breathing and the way we regulate oxygen levels in the blood. Okay? It's really important for respiration. You can also regulate blood pH. We know that pH affects enzymes because pepsin in the stomach doesn't work in the small intestine where it's pH 7, and likewise trypsin and lipases and pancreatic amylase doesn't work in the stomach. pH changes the shape of the active site so substrates don't fit. Remember the language of enzymes. And so pH is also kept pretty stable in our bodies unless we're in specific areas like the gut. Okay, so can you see that for all these things to take place in our bodies, but more specifically than anything, respiration, we need to have a constant environment which doesn't allow it to be hit and miss. Your body can't work if it's hit and miss, so we create a stable environment, which means it's not. It's always going to be pretty constant. So outside, you might have really cold weather, you might have really hot weather. Maybe that should be really hot weather and really cold weather. You might have, you might jump into a swimming pool that's got really strong acid. You might jump into the Dead Sea, which is really salty. But whatever's going on outside, your body and the body of most organisms are able to make sure that what's happening inside is kept pretty stable. They do the adjusting that's required. So that's the what homeostasis is, the maintaining a constant body environment. And that's the why, to keep things stable so these reactions can take place, and quite specifically respiration. And if you remember respiration, you'll also remember that I've always said to you that if you know the equation of respiration, then in fact you know loads about biology. Well, automatically in this one equation that I've just outlined, we have in fact got 3 really important areas of homeostasis just by knowing the respiration equation. You know that we need to regulate blood glucose levels. That's in the respiration equation. You know that we need to regulate body temperature, which is all based upon enzymes, which is other things that carry out respiration. I've talked about oxygen. We don't actually have to focus on oxygen so much. The other thing that we can focus on really nicely is ADH, which is antidiuretic hormone, which controls the water level in the blood. Now you might say, well, water levels? What's that got to do with respiration? I'm going to tell you. Remember that example I used, I hope you remember, where I got 2 beakers. And what I did was, I took 2 pieces of paper in an empty beaker with nothing in it, and they fell to the bottom and they weren't touching. Without water, without the correct concentration of water, if they would never meet. And if I put them in glue, really, really thick glue, they also wouldn't meet. But if I put them in a nice dilute solution, then the very easy movement of that fluid will allow those pieces of paper, the enzyme to meet. And that's what it's like in your cells. For respiration to happen, enzyme and substrate need to meet. And for that to happen, you need the right temperature, but you also need the right concentrations. Because if it's too gloopy, they're not going to meet. And technically, if it's too thin, they might meet too often. Okay? So the body needs to keep a nice level of runniness. Don't write runniness in your paper because that's not a biological term. Dilution is the biological term. And your body constantly monitors whether you've got enough fluid in your blood that goes into your cells to keep you all nice and fluid. So all of these things can happen. Remember, water is the medium of life. It is the reason that these things bang into each other and collide. Okay? So, automatically, by knowing the respiration equation, you're able to say why homeostasis is important. So how do we do this? Well, in our specs, if we just go up here, we can see the big one that they want you to really know about here is describing the role of the skin in temperature regulation, with reference to sweating, vasoconstriction, and vasodilation. And then also understand the sources, roles, and effects of the following hormones: ADH, adrenaline, insulin, testosterone, progesterone, and estrogen. Now, what I'm going to do is I'm going to just give you a quick potted view on how thermoregulation works. And the notes are actually really great here. But what I'd like to do is to point out a couple of areas as we go through the notes. So thermoregulation is the regulation of blood temperature. If they said to you, give 3 examples of homeostasis, thermoregulation, osmoregulation, and blood sugar levels are the 3 that you should really just be able to throw off, okay? And look at this. I've just talked to you about enzyme reactions and temperature being important, and there's the graph. Cross-reference to enzymes. If the temperature gets too high, the enzymes are going to denature. So we mustn't let things get too hot. But equally, if it gets too cold, respiration is not going to happen fast enough for us. We need that energy, okay? So make sure you're able to cross-reference that as to why we need the thermoregulation, okay? So, big key word here, all right, is the hypothalamus. So, hypothalamus regulates the temperature of the blood, okay? So remember, the blood's zooming around, and then the hypothalamus picks up senses it, and as a result of that, it creates a negative feedback system. Now, it's really important that you remember this. You're constantly monitoring the blood temperature in the hypothalamus. And if it gets too hot, it does what it needs to get it back up. So negative feedback is where you react to the information that you're given and correct it. Okay? Now, I don't propose to really go through these in real detail, because I think that this process is very straightforward, and if you've got any problems, let me know. But what I do want to do is point out those things that are going to be crucial on a mark scheme. Okay, so the main way the body controls temperature are sweating, shivering. Okay, now that's absolutely fine. All right, and controlling heat loss through the amount of blood which flows near the surface of the skin. Now, if you've got any problems with those, please just shout. Okay, but remember, in terms of why that happens, this cross-references with diffusion. If the blood goes near the surface of your skin, the diffusion distance for the heat, going from an area of high concentration, heating your skin, to low concentration outside to the colder air, is much smaller, so diffusion will happen that much quicker. If you vasoconstrict and you bury the blood in the vessels underneath the skin, much further underneath the skin, you increase the diffusion distance. Okay? And we know that as diffusion distance increases by 2, the diffusion time, the rate of diffusion, decreases by 4. Okay, remember the cubes, cross-referencing the cubes, where we use that die and we make different sized cubes. Okay, it's actually proportional to the distance squared. So if we can bury our blood vessels and make it twice as far for heat to diffuse, it will take twice as long. Okay, you need to learn the structure of the skin there. Okay, and the areas that I want you to make sure that you mention in terms of the mark scheme are talking about vasodilation, which is opening. When your pupils dilate, they open wider. Opening of blood vessels near the top of the skin. Vasoconstriction, which is where they constrict and the blood flow is taken away from the surface of the skin. Look at this in our mark scheme recently. This was another word. The reason that you lose heat is because the temperature, the heat required to evaporate water is very high. Water, because of hydrogen bonding, is stuck together really tight, and it therefore takes a lot of energy to evaporate it. The energy it takes to take the skin or the water off your skin and evaporate into water vapor is the energy that your body loses. Okay, and that, put the word evaporates in there. The energy required for water to evaporate. Okay, there's our word vasodilation. Okay. There's a great word. Heat is lost through radiation. Okay. There's our word vasoconstriction for cold. Okay. There's our heat, less heat loss by radiation. Okay. Less heat loss from, there's evaporation. Okay. And then here are the diagrams of the blood vessels. Okay. So when we're thinking about temperature loss or retaining temperature, the processes themselves are quite straightforward. You've just got to know those, and that is very much a learning exercise. But I want you to think about the whys. What is homeostasis? Yes, know that definition, 3 marks. Why? So respiration can take place. What does respiration involve? What would it need to keep the same for respiration to take place? And there you actually have the 3 homeostasis things that we study. Blood sugar levels, glucose and respiration. Temperature affects enzymes which control respiration. And how dilute your blood is affects how often things are able to collide with each other. Too dilute, they might collide too much. Too gloopy, like glue, they'll never meet. Okay? And they therefore control the very processes of life, and we cannot screw around with it. And that is why we have homeostasis.